Today, we would be covering the topic of cyclone. First, understand what is cyclone. Basically, cyclone refers to a low pressure area with winds spiraling inwards. So if you can see in this picture here, this is a low pressure area and the winds are they are spiraling inwards. And the cyclone basically rotates in the anti-clockwise in the northern hemisphere and the clockwise in the southern hemisphere. Let's understand this. So if this is a low pressure system, we all know that in the low pressure system, the winds converge from all the direction. So winds would converge here from all the direction. Now what's happens because of the Coriolis force. The Coriolis force deflects the wind in the right, in the northern hemisphere, and to the south in the southern hemisphere. Now because of the Coriolis system, these winds will get deflected to the right, and we have to visualize right from the direction of the wind. So if this is the wind, it will get deflected towards its right. This is the wind, it will get deflected towards its right. This is the wind, it will get reflected towards its right. Now what happens because of this is, this is a low pressure system wherein the winds, they have been deflected towards its right and they actually spiral inward. Now it appears that the system is rotating in the anti-clockwise direction when visualized from the northern hemisphere, and rotates in the clockwise direction when visualized from the southern hemisphere. The process of the formation of the cyclone and the intensification, increase in the strength, is known as cyclogenesis. Let's delve deeper into the conditions that is required for the formation of the tropical cyclone. So when we talk about the conditions for the formation and the intensification of the tropical cyclone, generally when do we see tropical cyclone? We see tropical cyclone in the late summers, that is somewhere in the September and October. The late summers, we will see tropical cyclone. Tropical cyclone are those cyclones which are found in the tropical region. So if this is the equator and this is 23.5 degree north and 23.5 degree south, you will not see the cyclone at the equator. We will see the reason why, and you will see cyclone in the tropical waters, that is between the tropics. Okay, between the tropics we will see tropical cyclone, and they originate over the warm oceans in the late summers. So what are the conditions which are required for the formation of the tropical cyclone? The first is the high sea surface temperature, nearly about 27 degrees Celsius. As we know that ocean actually warms up slowly. So ocean warms up to 27 degrees Celsius in the late summers. Therefore, one condition for the formation of the tropical cyclone gets fulfilled in the late summers. The second condition is the presence of Coriolis force. It is because of the Coriolis force that you will see the rotation of the cyclone in the anti-clockwise in the northern hemisphere. So we need Coriolis force. This is the reason why there is no tropical cyclone in the equator, because at the equator there is absence of the Coriolis force. The third important condition is firstly there should be weak low pressure area or the low level cyclonic circulation. So if there is already a pressure of, if there is already a low weak pressure that is found on the ocean, then the formation of tropical cyclone becomes all the more easy. It facilitates the development of the tropical cyclone. Now, why this has been in news recently? This topic has been in news recently because of the increasing frequency of the tropical cyclone in the Arabian Sea. So if we see the Indian Ocean, so this is the Indian Peninsula, this is your Arabian Sea, and this is the Bay of Bengal. In the Arabian Sea, there is formation of the tropical cyclone is increasing. What happens generally is, if there are 4 cyclones in the Bay of Bengal, we will visualize or witness one cyclone in the Bay of Bengal, in the Arabian Sea. This has been the historic trend. However, what is happening now is, out of 4 cyclones which we witness in the Bay of Bengal, the number of cyclones in the Arabian Sea is increasing. Because really 3:4 is the ratio now. So that is why it has become very intriguing for the scientists, climate scientists, to understand why are the tropical cyclone increasing in the Arabian Sea. And another thing that is happening is not only they are increasing in the number, but the timing is also changing. Why is the timing changing? How is the timing changing? Generally, it is witnessed in the post monsoon. Okay, that is somewhere in October. However, now they are being witnessed at an early time. At an early time. So number is increasing, the timing has changed, and the intensity of the cyclone has also increased. So cyclones have become more destructive in nature. They are more powerful. They have increased intensity. So when we talk about the historical trends have been, typically we will get weak cyclone in the Arabian Sea and two in a year. But now the frequency is increasing more. This has been dealt in the topic before. So why has the tropical cyclone increasing? Or if we see the historical trend, first analyze the historical trend. We are seeing the historical trend. What happened is generally there was more cyclone in the Bay of Bengal as compared to Arabian Sea. This is the historical trend. Now what is happening now is, now the number of cyclones are increasing in the Arabian Sea as well as the Bay of Bengal. But why is the cyclone increasing in the Arabian Sea? That is dealt by the scientists. So first understand the historical trend. Pehle, why cyclones were less in the Arabian Sea. So when we talk about the historical trend, we will see this in the Bay of Bengal. In the Bay of Bengal, nearly all the major rivers like the Ganga, Godavari, Krishna, Kaveri, they actually mix, the water of the rivers is being mixed with the Bay of Bengal. Now what happens here is, if this is the vertical zonation, we are going into the ocean deep. Okay, I'm vertically imagining the oceans. This becomes the surface ocean and this becomes the deep ocean. So here in the surface, you have this fresh water from river, and deep we have this cold water. Okay, the temperature reduces as we go deeper in the ocean. So what happens is, this fresh waters from the rivers that is basically falling in the Bay of Bengal is warm. Okay, the surface water is warm, and this warm water does not mix nicely with the cooler, deeper water. This is called as stratification. The different layers are strata, or different layers are formed with the warm layer above and the cooler layer below. Right. So because it is not mixed properly, it is more warm. This becomes a very good area for the formation of the cyclone. So now this is one of the reasons that in the Bay of Bengal there were more cyclones, right? Because the water was not mixing. As compared to Arabian Sea, the Arabian Sea do not have many rivers. So this phenomena is not taking place in the Arabian Sea, because not many rivers actually drain into the Arabian Sea. Therefore, the cyclone was more in the Bay of Bengal. Understand, we are talking about the historical trend. What has happened through history? Why there was more cyclone in the Bay of Bengal? And the other thing that was responsible for the greater number of cyclone in the Bay of Bengal was because of the shape of the region. So the shape of the region was such that it was partially enclosed, and the winds were slower here, and they actually could form and they were weaker, and therefore they could spin the ocean in a better manner. So not many winds were converging at the low pressure. Okay, so initially there was a weak low pressure, wherein the winds, they were slower, weaker, and they could converge across the low pressure and intensify this low pressure, as compared to Arabian Sea, wherein in the Arabian Sea, the northern, the western, and the central parts were cooler. So There was less cyclone here and more cyclone in the Bay of Bengal. This is historical trend. But now we are seeing that now what has happened? Now the number of cyclones are also increasing in the Arabian Sea. Any guesses why will it be? Yes, the reason is because of the global warming. Because the sea temperature is SST, that is sea surface temperature is increasing in the Arabian Sea also. So this increase in the temperature becomes a zone favorable for the cyclone. Coming back to the topic. So we are seeing that the cyclone in the Arabian Sea is increasing. We have already seen not only in the number, but also in the timing and the intensity. So if we actually see this area, you can see this map, wherein you will see that the cyclone Toktai was there in the Arabian Sea. The cyclone Maha, cyclone Vayu, cyclone Kayar, cyclone Hikka. These cyclones we have actually visualized or witnessed in the Arabian Sea as compared to the Bay of Bengal, which have witnessed cyclone Amphan, cyclone Fani and Bulbul. These are some of the recent examples of the cyclones. Cyclone Fani, cyclone Bulbul, this cyclone Nisarga. This if we recently the Indian Peninsula and the ocean has witnessed these cyclones. So getting back to the topic, that is the current trend in the Arabian Sea, increasing number of cyclone, the change in the timing as well as the intensity of the cyclone. So when we say increase in the timing, so there are certain facts like if you visualize from 1980 till 2021, so this is nearly 40 years. In the 40 years, for the first time, the Arabian Sea has witnessed pre-monsoon cyclone. Okay, 4 years in a row. So from 2018, 2019, 2020, 2021. In the last 40 years, 4 row in 4 cyclones in 4 years. Definitely there is increasing in the number of the cyclone, and this is also about the pre-monsoon cyclone. So generally the cyclones are in the late monsoons. Okay, but this is the pre-monsoon. Change in the timing and change in the frequency. You can also see that the 2018 witnessed Bay of Bengal witnessed 4 cyclone and the Arabian Sea witnessed 3 cyclone instead of 1. In 2019, the Arabian Sea had 5 cyclones. So 2018 there were 3 cyclones. 2019 there are 5 cyclones. So there is increase in the frequency. If we talk about the intensity, now intensity means the destructive nature of the cyclone, the energy that the cyclone carry, that is also increasing. So when the cyclones can be classified into severe, extremely severe, weak, other categories also are there. So this is just to make you understand that when we talk about the intensity, we are talking about the energy. It can be weak, it can be normal, it can be severe, it can be extremely severe. So extremely severe cyclone, okay, is being visualized. One extreme cyclone, severely extreme cyclone is being witnessed in the last 4 to 5 years. So in the 4 to 5, out of the 4 to 5 years, one cyclone has been extremely severe. Like example Nilofer, example May, cyclone. Okay, so cyclone May, example of cyclone Nilofer, these are the extremely severe cyclone. So this is about the destructive nature of the cyclone. Now we should understand that why is the cyclone increasing more in the Arabian Sea? One reason we have already seen, that is about the global warming and the climate change. So certain facts like, if we see that the Indian Ocean is increasing in the temperature of the Indian Ocean, if it is increasing by 0.7 degrees Celsius, okay, as compared to this, the Arabian Sea temperature is increasing by 1.2 degree Celsius. So the increase in the temperature in the Arabian Sea is more as compared to the overall Indian Ocean. And especially, this is especially around the Goa and the Lakshadweep area. So the Goa and the Lakshadweep area, there is more increase in the temperature. That is one reason. And scientists have told that nearly 64% of the cyclone in the Arabian Sea, so the increase in the cyclone, so nearly 64% is because of the temperature change and the climate change. So definitely climate change and global warming is one important reason for the increase in the intensity, frequency and the timing, the change in the timing of the cyclone. Because if the sea is warmer, there would be low pressure, greater low pressure development and the greater cyclone. The other reason is about the Indian Ocean dipole. Now, what is Indian Ocean dipole? You can see the video of Indian Ocean dipole. We will be coming with the video shortly. So when we talk about the Indian Ocean dipole, but here is a little introduction. So little introduction about the Indian Ocean dipole. What happens in the Indian Ocean dipole? So if there is this positive Indian Ocean dipole, the positive Indian Ocean dipole, the Western Indian Ocean is warmer as compared to the Eastern Indian Ocean. So this area becomes warm in the positive IOD and this area becomes cold, comparatively cold in the positive IOD. So what happens, because it is warm, this area is warm, there would be greater number of cyclones that can be formed. So this becomes, the positive IOD becomes the other reason for the formation of the cyclone or the greater formation of cyclone in the Arabian Sea. There are other reasons also like the Madden-Julian oscillation and the etc. Each of this would be dealt in the separate videos. So you can talk about climate change, global warming, the positive IOD, Madden-Julian oscillation, and the other atmospheric telecommunication effects of the El Nino, La Nina, etc. This is about the reasons. Now, we all know that cyclone is very destructive in nature. So after the reason, we would be dealing what would be the impact of the increasing number of the cyclone in the Arabian Sea. So what is the challenge that this cyclone or the increasing number of the cyclone is leading to? So it has a lot of issues like it leads to the destruction of the natural biodiversity. It leads to the destruction of the infrastructure, natural biodiversity in the form of wetlands, in the form of the the barriers. Okay, these are very good natural diversity in features. So it leads to the destruction of the biodiversity, infrastructure like roads, telephone poles, etc. It affects the agriculture sector because the saline ocean water comes into the coastal fields. Now, because of the saline ocean water, there is reduction in the fertility. So yes, there is destructive nature of the cyclone, which is harmful for the natural biodiversity, human resources, the infrastructure, agriculture, etc. Moreover, the loss of life and property is fairly well known. There is another important thing that is coming recently is that there is cyclone related displacement. You see, this cyclone would lead to greater displacement and then there is great increase in the number of climate migrants. The people who are migrating because of the climate related issues. Climate emergency that is also called as climate emergency related migration. So cyclone related internal displacement can be visualized because of the increasing number of cyclone in the Arabian Sea. An important thing that is being witnessed is the rapid intensification of the cyclone. That is, the cyclone's nature changes from weak to being strong to being extremely strong in a very short time. Okay, let's take an example of cyclone Toktai. It was a depression. Depression is a weak cyclone. Okay, just a small depression. It changed to the severe cyclone in just 2 days. Unlike which takes around 4 to 5 days, it changed from the depression to the severe cyclone in just about 4 to 5 days. What does that happen? What does this lead to? Because we cannot actually predict. We were expecting that it will take around 4 to 5 days, but it happened nearly in the 2 days. The cyclone changed its nature. Therefore, we could not actually go for efficient evacuation. Okay, there was less time that was available for evacuation. Evacuation means shifting the people from the coastal areas to the safe areas. So because of this, the increasing intensity in a very short amount of time, we got less time for the evacuation or migrating, letting the people into the safe area in a lesser amount of time. So cyclone is possessing a lot of challenges. Yes, like we all saw it now. So it is known that the cyclones would further increase because there is increase in the global warming. There is climate change which is being visualized. Therefore, we need to understand that we need to be prepared. Okay, this is a reality which has to be accepted and we need to be prepared. So whenever we talk of any disaster, we have to, like cyclone is a disaster, flood, droughts, these are disasters. So whenever we have to prepare for, we know that the disaster will happen. What is the way forward? The way forward is that you prepare yourself for the disaster. So in any disaster, you can use these terms like the preparedness, prediction of the disaster. Therefore, when we know that Arabian Sea is warming and it will continue to warm in the future, we have to be prepared and we have to go for risk reduction. Like we can use system like Indian Ocean observing system. So we have to observe the Indian Ocean and there has to be system to observe them. Therefore, Indian Ocean observing system. So technology have to be used, right? And we have to incorporate the global warming system in the weather model. So whatever weather prediction models, the monsoon model, the cyclone prediction model, the dynamic cyclone prediction model, we have to involve the global warming signals into them. Only then we can better evacuate people. Only then we can prevent climate emergency. So to do this, we have to be better prepared. Saying a goodbye with this, be prepared for your examination. And if you like our videos, click the bell icon and subscribe to our channel. Thank you. Signing off.